Okay, we're gonna spend the last 10 minutes or so class talking about inverse functions, and two of you who were with me last year might remember this diagram that I gave you, and I had you fill it out. And does anybody know what an inverse, what inverse functions are?
It's like the complete opposite.
Kind of complete opposite. Nicole, anybody else have an idea? What I want to do is I want to give an example.
I is the function of x.
I went to, I was looking at perhaps going on a vacation to Mexico City, and I saw that the temperature was 20 degrees, and it's the summer, and I say, man, how could it be 20 degrees? And I know Mexico City has higher elevation. But I'm saying, and I wanted to dress appropriately, but when I thought it was too hot in Mexico City, what was I forgetting?
They use
Celsius, right? Okay, yeah, so what Justin said. So what I need to do, because I don't really have the understanding that Celsius so much, is that, hey, I had to understand a conversion between them. Does anybody know the conversion of Celsius? There's a formula. I'm going to write it down quickly here. What it is, it's degrees Fahrenheit. Degrees Fahrenheit is going to be equal to 9/5 of the Celsius measurement plus 32 for 32 degrees. And so I know that if I plug in 20 degrees here, so in this case equals 9 times 20 plus 32, and so I would get, that's going to be equal to 180 over 5 plus 32, and 180 over 5, let's see, is that going to be like 36? Is that right? That's right, 36, Elizabeth. So I'll get 36 plus 22. So 36 plus 22, that's going to be 68 degrees. Now is that more like it? Yeah.
32.
So,
When I was thinking in my head, when you said it's 20, I was like, that's like 68 degrees. Swear to goodness. Just because 0 is
yeah. Well, the
32.
thing about it is, if you're experienced at it, you might be just good at that kind of thing anyway. You might have an intuition for it.
Oh no, it was a total guess.
Total. Okay, but let's say that instead we wanted to change this equation around to figure out, to go from Fahrenheit as an input to Celsius. How would we do that? What we're going to do, how would we do that? I'm going to rewrite the equation down here. How are we going to go ahead and figure out using Fahrenheit as an input instead of Celsius as an input? How would we do that?
Subtract 32.
Subtract 32, right? So let's subtract 32. So now we have 9/5 of our Celsius measurement equals degrees Fahrenheit minus 32, right? And then what?
Multiply by 9, or divide by 9.
Yeah,
Or 5/9.
Yeah, you can either, okay, Nicole's got it. We can either divide by 9/5, or let's multiply by 5/9. I understand that a little better. That is, so degrees Celsius is going to be equal to 5/9 of degrees Fahrenheit minus 32. Okay, so what we are dealing with here is these two functions are what we call inverses of each other. And so you're kind of switching places and solving for dependent variables. So that's kind of a real world application of what an inverse function is. And so we're going to go over some few things about what inverse functions are. And can anybody remember anything about inverse functions? Okay, there's inverse function notation. And Does anybody remember what that is? Okay, it's gonna be this f -1 of x. You remember seeing that someplace? Probably on that quiz I just gave you, right? But anyway, things to remember is x's and y's do what? Switch places. Okay, so that's one thing. The domain of a function is the range of its inverse, and vice versa, right?
What does that say? E-T?
The domain of a, oh, this one right here?
No, the first one.
Domain of,
Domain.
Domain of a function is the range of its inverse. Okay, so domain and range essentially switch for two inverses of functions. The inverse of a function is not always a function. And we do something to test for that called the horizontal line test. You've heard of the vertical line test, right? Well, horizontal line test is something we do to test a function to see if it has an inverse function. Okay. Then we say the two functions that are inverses of each other reflect about the line y equals x. And so this is a graphical representation. So this is going to be very important to us. So I'm going to just star this one. That's really important.
That are what? Inverse?
Two functions that are inverses of each other reflect about the line y equals x. Okay, so that's a graphical representation. Then up here, there is a 4-step process to find process or procedure to find the inverse of a function. And this is a really important one too. Okay, then finally one more thing. If two functions f of x and g of x are inverses of each other, their compositions, which is f of g of x, is going to be equal to x, and also g of f of x will be equal to x. And so this has to do with composition test. And for you, that has meaning in that we just went over compositions of functions. So you can test. So really, that's it, and that's really as far as I want to go today. Does anybody have questions about that? I do want to do one more thing. I want to draw a little sketch.
Wait, can you go back? Okay.
Yeah, so, real quick, okay, if we have a function here, this one here would be like f of x equal natural logarithm of x. It would have an inverse function like this. That's going to be g of x, we'll say, equals e to the power of x. These two functions, graphically, do you see they reflect about this line y equals x? Yeah, so that's gonna be a graphical test. And so really, that's it. Thank you for participating today.